Good evening. Today's class is all about voltage division rule and current division rule, and this is an application of Ohm's law and Kirchhoff's laws what we have learnt in the previous class. Just to recall, what is Ohm's law? The voltage across the resistor is directly proportional to the current flowing through it at constant temperature. You know, resistance is the opposing property for the flow of current, and that will be defined by R is equal to rho L by A, where rho is the resistivity and L is the length of the conductor and A is the cross-sectional area of the conductor. So resistivity will be good for copper, gold like conductors, and it will be very high for glass, paper like insulators. So resistance is low for good conductors and resistance will be high for insulators. As per Ohm's law, you know, V is equal to I into R, where I is the flow of current through the resistance R, V is the voltage appearing across the resistance R. And you can also write the reversing values. I is equal to V by R and R is equal to V by I. During short circuit, the resistance will be 0, and during the open circuit there will be high resistance that will be of infinite value. And in Kirchhoff's current law, the algebraic sum of the currents entering a node will be equal to the currents leaving the node. So sum of the currents at any node will be equal to 0. You can write the expression for Kirchhoff's current law for the given circuit, where we have only one node. Some currents I1, I2, I4 are entering, and I3 and I5, these currents are leaving. So sum of the incoming currents is equal to sum of the outgoing currents. And Kirchhoff's voltage law, you know, algebraic sum of the voltages around any loop will be equal to 0. If you have m number of voltages in the loop, Vm is the mth voltage in the loop, we say that summation of Vm is equal to 0. So while writing this equation, either you can travel the circuit either in the clockwise direction, otherwise in the counterclockwise direction, but both direction is going to give you the same result. So let us consider this series circuit. R1, R2 resistors connected in series with the voltage V0. V1 is the voltage appearing across R1 and V2 is the voltage appearing across R2. Since these two resistors are in series, the same current I is going to flow. Let us first consider the clockwise direction. We write minus V0 is equal to, if it is clockwise, minus V0 is equal to plus V1 plus V2, that is equal to 0. If it is in the counterclockwise direction, the expression is minus V2 minus V1 plus V0 will be equal to 0. Anyhow, V0 is equal to V1 plus V2, that is the final equation of voltage. Let us consider the same series resistor with two resistance R1 and R2. So let us now find the equivalent resistance between these two in terms of writing the voltage expressions. We know V0 is equal to V1 plus V2. Now applying Ohm's law for writing V1 and V2 expressions. V1 is written as I into R1. V2 is expressed as I into R2. So we can combine this. So the equivalent resistance is R1 plus R2 if it is in series. So let us represent it as R series. So the equivalent circuit for this circuit with a single resistance is V across one series resistance, that is R1 plus R2. Now coming for voltage division. Now you can write the current expression for the same circuit. I is equal to voltage appearing across it by the series resistance. So the total current I is equal to total voltage divided by the total resistance, that is the equivalent resistance obtained by the series circuit, that is R1 plus R2. Now let us try to write V1 and V2 in terms of I and the resistances. So V2 is equal to I into R2, that's from the Ohm's law. So now let us substitute the current expression what we have derived here. V0 by R1 plus R2 into R2. So V2 is equal to total voltage into the corresponding resistance for V2, that is R2 divided by the equivalent resistance R1 plus R2. Similarly, we can write V1 is equal to the total voltage V0 into the corresponding resistance R1 divided by the equivalent resistance R1 plus R2. Now coming for parallel resistors or parallel circuit. So here two resistors are connected in parallel. So in case of series circuit, the voltage divides, but in case of parallel circuit, the current is divided. So the current I is dividing into I1 and I2, but the voltage remains same across R1 as well as R2. So it's equivalent circuit. We can, instead of two resistors, now we have to draw one resistor, and let us see the equivalent resistance Rp with R1 and R2. So I, the current as per current law, I is equal to I1 plus I2. I1 can be written as V by R1 and I2 can be written as V by R2. So you can write the total current I is equal to total voltage into 1 by R1 plus 1 by R2. So this you can replace with the equivalent reciprocal 1 by Rp. So what is Rp then? You can derive from here. Rp is equal to R1 R2 by R1 plus R2. So for current division, let us express just in terms for identification. I am writing as a function of time I of t. So the voltage is also a function of time V of t. Just a change in the current because this circuit is applicable for both the AC circuit as well as DC circuit. So let us write in terms of time. So the voltage V of t is equal to the total resistance into the total current. So the total resistance we have derived for parallel circuit is R1 R2 by R1 plus R2, and the total current is I of t for this circuit. So I1 of t is what? As per Ohm's law, V of t by R1. So substituting this V of t R1 R2 by R1 plus R2 into I of t divided by R1, R1 get cancelled. So we get R2 by R1 plus R2 into I of t, and similarly I2 of t is equal to R1 by R1 plus R2 into I of t. Now here you can observe the current is inversely proportional to the resistance. So current in one resistor is proportional to the current in the other resistance. It depends upon the current in the opposite branch divided by the equivalent resistance. So current divides inverse proportional to the resistances. So what we have observed so far, in case of current and resistance are inversely proportional. That will give the current division rule, and in case of voltage division rule, voltage and current are directly proportional. That's what's today's class. Thank you.